What a start. Hello, everybody. Thank you for joining us at this session. Generative AI asking for a friend. How is everybody's reInvent? Yay! Woo! Excellent. I'll just let you know that we are here in Mandalay Bay, as you know. We're also being joined on a simulcast by an audience who's in MGM Grand. How are you? I think I heard them, yeah, and also in the win as well. My name's Mike Chambers, and I'm a developer advocate for Amazon Web Services.
And my name is Tiffany Souter. I'm also a developer advocate, specialist in AI/ML at AWS. And yeah,
we'll start off
yes.
by doing one of these. I don't know if you've seen these.
Yeah.
I haven't worked with one of these before, but this is a bit of a survey. So you can all join in, no matter where you are watching this, but you can take a picture of this QR code, or do you know the thing, and you tappy, tap, and you should get a poll. And we're asking this question, has generative AI
has generative AI changed the way you live? Has it changed the way you live, Mike?
Absolutely, it's changed the way I live, because I'm standing on this stage here. I don't think I'd be doing
because
that
of that.
Generative AI.
Yeah.
What about you?
It definitely has changed the way I live also, but it's probably because we work in this field, so it has a huge impact on our work, but we'd be very curious to know if it has changed the way you live.
Absolutely. And so, oh, look at that. We've got some results coming in live. Excellent. Yes and no. That's very indecisive.
Yeah, that's surprisingly indecisive.
I don't know. A little bit, maybe not.
We were not expecting that, actually.
No, I was thinking maybe it would be a little bit more on the side of yes. I guess we didn't actually take part in this as well. Okay. Well, that's interesting. I guess it'd be interesting to know after the end of this presentation whether you've got sort of similar feelings or whether you're a little bit more positive maybe about generative AI moving forward. So we can look at that as well. Should we hop into the agenda for today?
Yes. So today we are going to answer a few questions. What is generative AI? What are language models? How does text generation work? What are foundation models? How do you use LLMs? How do you customize LLMs also? What is a retrieval augmented generation? What are agents? And also we're going to talk about Amazon Bedrock.
Absolutely. And so I think it's important to look at those questions. We're going to answer some of the fundamentals, but we actually want to go through to some of the more current topics that people are talking about in generative AI, make sure everyone's got an understanding of that as well. So, and if time allows, maybe we can open up to questions from this room in Mandalay Bay as well.
Yeah, so generally, what is generative AI? We hear a lot about this, especially for the last year, but most of the time people don't exactly know what is generative AI. It's actually a subset of artificial intelligence. Before all of the generative AI hype, you might remember in machine learning that, for example, we had models that were very good at classifying things. For example, if you give it an image to analyze, it was able to tell you if it was a dog or a cat in the image.
It's always dog and cat.
Yeah. Well, dog or cat, a car. But it was able to do recognition, but it was not able to draw a cat or to draw a dog. And that's generation. And generation, like generative AI, basically is specialized in generating new data that it has not seen before in a training data set. And so you could now send a prompt writing a golden retriever wearing glasses and a hat in a portrait painting, and it would generate that image that this image has not been created by anyone before. Like the AI has generated that. Also the same with a question. You can have a conversation with an AI and it will give you back that answer that is completely customized to the question you've asked.
We're doing another one. So we're not going to do this the whole time. It's not like one slide. Then we'll ask you another question, invite you all up on stage. Let's just do one more, and then we'll crack on, and then we'll have one more towards the end as well. So has generative AI changed the way you work? So I think before we were asking about the way you live. What about the way you work? Is it ingrained in your workflow? Is it something you're actually developing with at the moment as well? That's another question we have. Hopefully you got that in time.
A little bit more. That's interesting.
Yes. Actually, we didn't ask, has it changed the way you work in a positive way? Hopefully it has changed the way you work in a positive way. We've got some...
Well,
we've got
you know,
no.
that would be a debatable question. You know, we probably don't want to have this debate here now.
Sure. Okay. We'll go to a coffee shop afterwards and talk about this. All right. Okay.
Off camera.
Look, I appreciate you answering those questions. Thank you. I hope you find it interesting to see what everybody else thinks as well.
So can you tell us, what are language models?
What are language models? Well, and so we're talking about generative AI, and one of the most, the key developments and where we're seeing the most business value at the moment, particularly, most value, is in the language models that we're using. And so I just wanted to explain a little bit about where these have come from. Why is it that we're talking about language models today and now, and we weren't necessarily talking about them so much a couple of years ago? And so I want to just recap, just briefly, the road to generative AI. How did we get to where we are now? And it all starts back at the beginning with word embeddings. So word embeddings are a statistical way of being able to draw relationships between words. That's really all they are. So we take as many words as we can find in natural language. So, I don't know, everything that we can find on Wikipedia, everything, or the complete works of Shakespeare, whatever else we can find. And we start to analyze that and see the relationships between words. And this is something that we've been doing, by the way. This road goes back at least 10 years, maybe a little bit longer than that, in terms of really serious of working in this space. And I can't show you word embeddings in the space that we would normally, or that they exist in, because they're a multi-dimensional space. And unfortunately, as much as we are a technology company, and this is a technology conference, my display only shows 2 dimensions. I do apologize. So this is our 2-dimensional graph, and we'll have a look at the relationships, a simulated idea about what the relationships between words might look like. And it's coming up again, the dog and the cat thing.
Yes.
It's a common theme in machine learning that we talk about dogs and cats and abalone. But anyway, so this is where dog might sit in our 2-dimensional vector space. So we've seen the word dog used in natural language, and then let's put it in the context of something else. Yes, it's going to be cat. And we see that dog and cat coexist in this space. Like they relate to each other in this 2-dimensional space.
And the way we calculate the relation between those words is the way they are used in the language. So cats and dogs are often seen close to the same words, like running after something or eating a biscuit or playing with something. So this is how mathematically we can say that those words are close to each other. It's because they're often used with the same other words.
And on the juxtaposition to that is that we've got car, and car is not particularly related to dog or cat, although dogs do sometimes chase cars, in this particular space anyway, but it is related to bus. It's a different kind of transport, I guess. It's another vehicle. And so if we put onto this graph all words in the natural language, of which this is a subset, this is not all words, you can see that it does map out. You can see the relationships between words. And these relationships between words in these word embeddings are the basis of language models. And so the language models that we're using today share their roots with this.
And so just to add a little bit, mathematically what it means is that the location of the words is the position of their vectors. If you might have heard of this, when we vectorize a text, it basically that we give a position in the space to those words.
That's exactly it. And so in years gone by, we would use these number of different algorithms, including the word2vec family of algorithms, to help us to be able to process large amounts of text and come out with these basic language models. And this allowed us to be able to work in the field of what we used to call, I guess we still do, natural language processing, or NLP. And so the kinds of tasks that we could do back then, and we can do now as well, are things like text summarization. So we could train a model to do text summarization. We could train a model to do question answering. We could train a model to do sentiment analysis and also speech-language understanding, which is basically the technology behind products like Alexa, where it understands human intent. So that was what we did. And with those kinds of language models, how could we use those to generate text? Well, what we tried to do is we tried to predict the next word. There's a lot of that going to be in this presentation. We're trying to predict the next word. And so in this particular example, we have a sentence, and we know the last word of that sentence, and we're going to try and predict the next word. And we're going to use that using very simple word embedding techniques. Now, at the moment, we can't see the rest of that sentence. And the reason why we can't is because the model can't either. It's just looking at the last word, lazy, and figuring out what the next word could be, might be, prediction. Machine learning is all about making predictions. And so based on the fact that it's lazy, we could guess, I guess, that maybe it's person. A lazy person. It makes sense. From a language perspective, it makes sense. It could be that. Is it that? We don't really know because we can't see the rest of the sentence. What we needed to do was try and find a way to get more of that context, more of the what was in the rest of the sentence. And so we worked on this over time, and I'm talking us as society, and we come up with recurrent neural networks and technologies like this. And those recurrent neural networks can actually see more of the context and see more of that sentence. And so now we can see a little bit more about what's going on here. The more words we try to include in this calculation, by the way, not quite technically exponentially, but we get a big growth in the amount of compute power and memory that's required to make this calculation. So not particularly efficient by today's standards. And so we can see Fox jumps over the lazy something, and now we're trying to predict the next word. Now, I need you all to pause your human squishy brains, which probably knows exactly what's going to come next, and think about it from the perspective of the model. The model's just looking again at just similarities between words. And so it's going to make the prediction of rabbit. That could be it, right? That makes sense. A fox and a rabbit, they might coexist in the same space. So we're making predictions about what the next word might be. The point is with this older technology that it wasn't very good, it wasn't very accurate at predicting what we wanted because it just didn't have the ability to have the whole context of the sentence. So what changed? Why are we here now? Why are we all very familiar with our chatbots that are capable of doing amazing things? Why are we talking about generative AI? And the pivotal moment was in 2017. Now, I'm not going to go through very many white papers in this session. Don't worry, but please lock the doors. We're not letting anybody out. This white paper, Attention is All You Need, was released in 2017, and it really changed everything. Because inside of this paper, they discussed this diagram. And I'm now going to spend the next week explaining everything that's in this diagram, but this is the transformer architecture. And this is, honestly, a much more complicated architecture, but very, very powerful. And it's what has enabled us to be able to train the models that we're seeing today. All of these amazing things that you've seen with generative AI, they basically owe their thanks to this model in some way. It's been adapted over time. It allows us to be able to process much larger data sets and allows us to be able to parallel process that data to make much, much larger models which are capable of seeing much more of that context in terms of when we're trying to make the prediction about what the next word might be. So here's a sentence. It now says, the quick brown fox jumps over the lazy. Many of you probably know what the next word probably should be. It was an unfamiliar sentence to you, am I correct?
I wasn't familiar with this before.
But we saw it a lot when we were rehearsing it.
Yeah.
So it's dog. So it's the quick brown fox jumps over the lazy dog. And obviously, if we've put that into a generative model these days, we don't just get that. We actually get lots more as well. This is a subset of the response that I got from Anthropic's Claude V2 model, where it actually says, well, it appears that this is the English pangram. And for anybody who's not familiar with that, this sentence contains every letter from our alphabet at least once. I think it's useful for people practicing typing. So that's what we're capable of doing with generative AI now. Thanks to the transformer architecture, we got much more visibility of the context that we're working with.
So how does text generation work? We are going to try to explain what we've seen before in a very simple way. So this is very simplified, but basically what happens with a transformer is that you have your model, and so that's the LLM, and you have a request, a query, so that would be your prompt, your input. For example, here it's, my name is Marigold, and so that's what you send to the LLM, and the LLM is supposed to generate what's going to come next. And so what you do is that you give it the entire prompt, and then the model will predict the next most probable word. And what you do then, after that cycle, is that you take all the sentence, like the query that you send at the beginning, plus the word that has just been generated, and you feed it back to the LLM, and it predicts the next words, and so on. And it does that in a cycle until it gives you the entire sentence. So this is how transformer work. And you have here in the output the completion. So my name is Marigold, and I am a golden retriever puppy. But just so you know, the LLM doesn't have a memory. Every time you ask for the next word, you give back all of the input in the context. So yeah.
It's like it's never seen it before.
Yes.
I thought you were Tiffany, not Marigold, but okay.
So what are foundation models? Basically, foundation models are very, very large models that required a lot of data and a lot of power compute to make. So it is not everybody that can make a foundation model. It could cost a lot of money. It takes a lot of time. It requires also a lot of expertise. And you might not want to make your own foundation model because that's going to be very costly for you. And that's why big companies have made foundation models available to you. So now you can query those foundation models just with an API. And in Amazon Bedrock, we have available different foundation models. Here you have Jurassic, Titan, Claude, Command, Llama, and Stable Diffusion. How do you choose the foundation model that you want to use in your use case? Basically, they are specialized for different tasks. For example, Jurassic 2 is best at doing multi-language answers. So if you need to have different languages, like let's say French, English, Spanish, and so on, then you might want to use this one. If you want to do text generation, then Claude might be the best choice for you. Or if you want to generate images, then it's going to be Stable Diffusion. Depending on your use case, then the foundation model that you are going to choose is different. How do you use LLMs?
How do you use LLM?
Yeah.
Yes, well, let's take a quick look. So what I wanted to do now is jump into my laptop and press the button down here, and I've got it. OK, and so we're into the Amazon Bedrock console. And really, the reason for doing this is because I wanted to show you some of the techniques that we use to work with large language models, particularly, and some of the parameters that we can send to them to cause the generation to work and to be different. So this isn't a comprehensive review of Amazon Bedrock, but I'm using Amazon Bedrock because it's got some interesting features inside of the console. So this is the console, if you're not familiar with it, for the Bedrock page. And if I just look down the side here, you've got the normal menu that you might expect to see inside of the console. And there are a couple of things that's probably worth just pointing out here. So we've got overview pages and things that you might expect. And so some of the things that Tiffany was just talking about here, this is, you can see the logos that we had from the slide before. And you can click through to some of these models. It'll explain in more detail about what it is that they're best suited for. And also, if new foundation models are made available through Amazon Bedrock, you'll be able to find them in here as well. So it's pretty easy to set up and get going and see some examples. Now, down in the middle on the side here, we've got the playgrounds. And so the playgrounds are really useful for being able to start, especially your developer journey. So if you are developing code or you're working with developers who want to work with large language models, it's really important to experiment because you've got things like trying to figure out which model do you want to use, how do I want to structure my prompt, what's going to come back. You can do that kind of stuff in code, but it takes a lot of cycles to deploy that, try it out, try again. And so really do encourage you to start off inside of a playground like this. So we have a couple of different playgrounds with text, chat, and image. And so I'm going to go to the text playground because that allows us to be able to work with large language models. I'm just going to scroll back up to the top here, get rid of the menu at the side, just make it a little bit bigger so we can see it. So this text playground is going to look a little bit like a chatbot interface, but it's not. What it allows us to be able to do is send a prompt to the model and then get our generation back. And then it won't remember anything, and we can do it again, and we can experiment around with how the model works. This is the most fundamental way, if you like, that we can work with the model. And so we could type in here, my name is Marigold and whatever would happen, and probably wouldn't because of the non-deterministic nature of large language models. It probably wouldn't say I'm a golden retriever puppy, but So what we need to do now is we just need to select our model that we're going to work with. So I'm just going to select the Select button. You can see the model providers that we have here. So AI21 Labs, Amazon, Anthropic, Cohere, and Meta with the Llama model. And so I can go ahead and I'm going to select Anthropic, and maybe for this one I'm going to select Claude Instant 1.2. So lots of different models, different price points, different sizes, different speeds, different capabilities. So if I select that model, and I just have to scroll down to the bottom here because it's just off my screen, hit the apply, and now we're in and using this model. Now, again, I'm just going to get rid of the menu here. And now I can start to prompt my model. And you can see is I've got this text input. So if you're familiar with using chatbots, this is where the text goes, this is where your prompt goes. But I also have these configuration options at the side. And this is something that I wanted to talk about in this particular session here, this part. So we have temperature, top P, top K, maximum length, and stop sequences. So if we're working with large language models in our applications, these are the kinds of settings that we want to know about, because it can influence the way that the model works. We can have a little bit more control over the way that the model is going to respond to us. So let's have a go at doing some live prompting. Who thinks that's a good idea? OK. Actually, what I'm going to do is I'm going to switch over to this one, because I've already typed it in. I don't want to make a spelling mistake and stuff like that. So in this page here, we've got a prompt ready to go. Now, it looks a little strange, right? So we've got a couple of blank lines at the top. Then we've got human colon, and then some text, in this case, the prompt. Write a one-word summary of Las Vegas. What could possibly go wrong? Nothing. And then we have assistant colon at the bottom. Now, that's because I'm using the Anthropic Claude model. And so Claude has a particular way of prompting. And it's like this, a couple of blank lines, human colon, we write what we want, and then assistant colon, and then we're looking for the model to generate its response after that assistant colon. Now, if I didn't type that in, the console would do it for me because it knows it needs that, but that's why it looks like that. It's basically a chat-enabled or a chat-optimized bot, you could think. So let's just run this as is and see what happens. I'm asking for a one-word summary for lots of reasons, and it means it's going to happen quickly. We don't have to wade through lots of text, and it's come out with casino. That seems kind of reasonable for a one-word summary. If I think of Las Vegas, one of the things I think
Thankfully,
about
you didn't say anything else.
Yes. Well, do you know what we should do? We should run it again. Let's have another go. And so let's see what happens if I run it again. I get gambling. Well, that's, again, something that sounds about right. So we're getting different words out of the large language model. What's going on? It feels like it's kind of random. It seems like there's a random number generator in there somewhere.
Yeah.
And there absolutely is a random number generator in there. And it's basically choosing words that might be the right output or might be what you're looking for. And then from those, it's making a bit of a random choice. That's why it's creative. That's why when you go to a chatbot and ask it the same question today and then the same question tomorrow, you might get a different response because there's a bit of randomness going on. Now, when we're developing our own code with large language models, we get to influence that. And that's what these settings are over at the side. So I'm just going to run it one more time. I'm going to really push my luck here and see what we get. We got gambling again. I'm going to press it again until we get something different. Casino. OK. Was that the first thing it said? No.
Yes.
Was it?
It
OK,
was.
all right.
Yes.
It's changing it up. OK. Live demo. Right, let's try adjusting this. And we can do that at the side here with temperature. And basically, the way that you can think of temperature is making the model more or less creative. Right, so the higher the temperature, the more creative the model is, or the more creative the output is. The lower the temperature, the less creative it is.
I mean, by creativity, we mean that you give it more freedom.
Yes.
In the probability space to choose the answer it's going to give you. So it might be less accurate, also in the answers, but it will try to visit other spaces in the probability space to give you like more creative answers. Yeah.
Visiting places in the probability space. I want to go there. OK, so I've taken the temperature all the way down to 0. So I've reduced it as much as I can in this particular console. And I'm going to run it again. Now, it might come back with something we've seen before. It's going to come back with gambling. OK, now if I run it again, and I press run again, it should come back with gambling.
Demo time.
Now, if I stand here for the rest of this session pressing run,
until it's being creative.
two things are going to happen. One, it will keep saying gambling because it's now really not being creative anymore. And two, you will all leave. So I'm not going to keep doing this. But trust me, it will keep coming back with gambling. And now we can adjust it by typing in something different there. But we'd have to turn that temperature back up in order for it to start generating more things. So this is useful, right? So if we're doing something where we're asking the model to produce code, which is something we could do, then maybe we don't want it to be creative. We want it to be a little bit more deterministic. Otherwise, if we're looking for it to write a poem, then we could move that needle all the way to the top. So top P and top K are similar kinds of controls that, again, influence the diversity of the words that it's looking to use for its generation. And there is more information you can get from the info bar, so I'll let you have a look at that in your own time. Other kinds of configuration options here are things like maximum length. This is super useful. Because I'm only generating one word, I could literally bring that down to a small number. Now, this is tokens, not words, which there's a nuanced difference between this, but I could bring it down to be something quite small. If I was to say here, write a summary, I'm really pushing it here, write a summary of Las Vegas rather than just a one-word one. And I reduce this down to, I don't know, something under 100 and press run, then we might get some kind of generation, but look, it finishes at this something. And you're all scanning it now to see if that's libelous or anything, but it finishes halfway through. Now, if we're using the API, it would actually tell us that it's being truncated and cut off, so we could switch that back up. And so this is useful because when we're using large language models, when we're using generative AI, we're often billed on the word or token level. So having some control over it with the maximum length is super useful. So if I push that up to the top, and press run again, we hopefully will get something which then gets all the way to the end. And that's pretty fast, right? And pretty comprehensive answer, hopefully. And obviously, super, super simple prompt. If we wanted to get a little bit more in depth, we could give it quite a lot of context about the kind of thing that we want it to do. So that went okay, I think. That was a demo of using...
The creativity did not work, but...
Yes. All righty. So, how can you customize a large language model? So we've just looked there how we can prompt in different ways, subtly. We did a couple of different prompts, one word or not. And we can see that prompting it in that way can produce different kinds of outputs. But we've probably all heard of hallucination. Who's heard of hallucination? Yeah, we've all heard of hallucination. It's one of the challenges of using generative AI as a whole is how do we control the output even more than the kinds of things that we've just looked at. So how can we customize a large language model? Now, Tiffany was talking before about the foundation models. One of the things you could do is you could go and build your own model. But I think, as you suggested before...
It's probably not the best idea.
That's not a rainy weekend project, right? It's not. It's going to cost you a lot of money. It's going to take you many months to do. So it's certainly not the first port of call. So if you're struggling with the outputs from the models, I wouldn't recommend starting off by building your own model. Another thing you can do is continuation training. So you can take a foundation model that already exists, and if you have access to the actual model itself, so an open source model, for example, you could take that model and you could get your own training data and you could carry on training it. That's totally possible, but it's still quite a big job. So not necessarily your first port of call. You can also fine-tune, subtly different from continuation training. This is where we give it examples of, well, for this prompt, this is the answer I would like. And you can use big data sets like that to refine or fine-tune the model to make it more task-specific for the kinds of things that you want to do. So if you're working in a specific industry, or more to the point, your business works in a certain way where you want the generations to be a certain way, if you've got a data set already, I like my things summarized like this, then you could fine-tune it. That works too. But still, I wouldn't necessarily recommend that as the first port of call. I think the first thing to do is to take a look at in-context learning. And this is where we start to look at the topics that you might have heard of spoken about this week, and in Adam's keynote as well, where we talk about retrieval augmented generation.
Yeah. So basically, what you do is that you have your LLM that is not specialized, like you have your plain vanilla foundation model, and you send it the prompt, so that's the query. And what you can do for in-context learning is that you give more data to that prompt. So basically what happens here is that you basically send the request, the query that you want to send to the LLM, but then you give it also very accurate data about, like, that could help the foundation model answer the question. And where you get that data could be from different sources. It could be from vector databases. It could be from an API that can query and then sends back the data to the prompt. Basically, what you do is that you enrich your prompt with more information. And that's RAG, Retrieval Augmented Generation, and you have a nice explanation, like a nice metaphor as to what RAG is.
You're saying this has something to do with me? I don't know. Okay, yeah, look, so Retrieval Augmented Generation. Sorry, I stole your punchline. Yes. So we want to explain a little bit about this and how it works. There's some misconceptions out there, and so it's actually a really interesting architecture. So let's step through it. And I thought the way that we could do that would be with a little story. So let's now not think of a large language model as a computer model. Let's think of it as somewhat of a person. I'm not a fan of anthropomorphizing, making human characters out of large language models, but I'm a fan of this one. So this, we haven't got a name for this character.
The wizard.
The wizard.
Okay.
Wizzy the wizard?
Yeah.
This is Wizzy the wizard, just named. And Wizzy the wizard is learning magic. This is our large language model for the sake of this demonstration. And initially, obviously, an untrained model can't do very much. Poor Wizzy the wizard doesn't know how to do any magic at all. So what do? I think we probably all know what we do is we send Wizzy the wizard to school. And we send Wizzy the wizard to a wizard school where Wizzy the wizard learns how to do magic. And so we are essentially pre-training our large language model at this point. So now we can do magic, right? This is great. I know how to do everything. So I'm not Wizzy the wizard, of course, but go out with my wand, see a troll. I need to protect people from that. What do? I don't know how to do that. I don't know how to protect people from trolls. I know how to cast spells. I know that. I know how to swish the wand, but I don't know how to actually do that spell. So what do? Well, one thing we could do, I suppose, is we could go back to school. Could we do that? We could do that. And we could go, but by that point, you know, the troll has caused the havoc, and we haven't been able to save people from that. So we don't go back to school and sort of learn every single spell that ever existed. We want to be a little bit more in the moment. And so we grab our spell books. So our spell books contain all of the information that we need in order to be able to perform the task which is right in front of us right now. And this is what Retrieval Augmented Generation does, because we can give the large language model, the wizard, access to our data, the spell books. So we don't have to always go back to the knowledge that the model had when it was initially trained.
And also, one of the interesting things about this is that I was about to say the LLM, but going back to the
Wizzy the wizard.
The wizard, when going out of the school, it has knowledge that stops at the end of its training.
Right.
And so with this, it's the same with LLMs. You know, it has the knowledge up until the day it was trained, but then if you want data that has been generated after, like if you ask a question to an LLM about something that happened this week, but it has been trained in 2021, then it would not be able to recollect that data because it has not seen it yet. And that's the thing with Spells book, like you can have a book that is up to date, and so the LLM is just able to query that data and being able to be up to date with like fresh data that is
the brand new spells.
Brand new spells, exactly.
Absolutely. Now, you can find, so why would we ever have continuation training? Why would we have fine-tuning then, if we can just do this? Well, imagine the situation where Wizzy the wizard goes to the spell books and opens up the spell book and reads stuff and says, I don't understand this. This is higher level magic here. I don't understand some of the ways and methods that are in here. So at that point, that's when we can send Wizzy the wizard back to training school and do some fine-tuning or some continuation continuation training. That's the kind of time when we're going to look for that kind of thing. To say, okay, well, now you understand other concepts so that you can then work with the data that you have. So in a different non-wizarding world, if you imagine that you're working in financial services or in medical applications or in legal applications, something like that, something where language is somewhat different from the everyday language that we use, different from the everyday language that the model might have been initially trained on, where you can do your continuation training, maybe some fine-tuning, to bring the model up to knowledge so that it knows how to work in that world. It still doesn't need to know the specifics of everything, because we can give that through retrieval augmented generation and through the spell books of the lawyer world. So, agents. So another term that you might have heard of, again, this week, and in Adam's keynote, we mentioned a couple of things there, and one of the things was agents and tools. So what are agents? Well, we actually have all of the components already in this story to be able to talk to this and to talk to what agents are. So we'll go back to this. And if you want to take a picture of this slide and say, this is the kind of slide I saw at reInvent, I don't know. Here we go. This is agents. So the ability to send messages elsewhere, the ability to be able to interact with other systems. So in this particular case, yes, Wizzy the Wizard can send messages off and can request things, can send information away, queries away, and get responses to come back. In the large language model world, in our applications world, this might mean connecting into an API. Booking a flight, sending an email, even doing something as simple as finding out what the current date and time is. Because think about it, large language model has no idea what the current date and time is. So having an agent for that is genuinely a really useful thing to have. So that's our architecture diagram for this session. I hope you like it.
So going back to a less wizardy world, we have Amazon Bedrock, which is basically a tool that can help you use everything that we've talked about, but more easily in a fully managed way. So Amazon Bedrock is a framework where you have, as we showed earlier, all the foundation models available. So you can query them with an API. You also have the knowledge base. So the knowledge base is basically, so the foundation model is the wizard. And now we have the knowledge base, which is the book of sales. And this is where you put all of the relevant data for your business. Anything that obviously the LLM hasn't seen before in the training, basically some data that, it could be data that is private to your company internally. Obviously, a foundation model doesn't know specifically what your company is working on or the data that you have internally. But what you can do is put all of this data inside of an S3 bucket. And you give to Bedrock the URL to your S3 bucket. And Bedrock will take care of everything for you. It will take the data in your S3 bucket, vectorize it, and put it in a vector database. And so it will be something that then the model would be able to query. Also, in Bedrock, you have access to agents. And so, as Mike said before, agents are able to perform tasks for you if you give it the right API and the right permissions. So basically, if you want to book a flight, for example, send an email, and you have the right full API to do that, then you can specify it here in Bedrock.
Order a new broomstick.
Yeah.
Maybe as well. And we are contractually obliged, and anybody who's been at AWS conferences before for a while will know this. This, like nothing else, is undifferentiated heavy lifting. So we are required to say that term. We're not really. But this is absolutely what this is doing. So as Tiffany was saying, like taking your data and actually putting it into retrieval augmented generation. There are a number of steps which are fairly tedious and laborious to do, and this will do it for you.
Yeah, you could build the entire thing on your own. You could build your own vector database. You could vectorize with your own embedding models. You could, you could create your own agents. But that's a lot of work that you wouldn't have to do if you use a completely fully managed framework.
Absolutely.
And so last question to you guys.
One more question. And then we'll take live questions, I guess. But one more question.
Yeah. Do you think generative AI will change the world in the future?
And again, frame that in whatever context you like, but I think we're framing it in a positive context here. And the kinds of things that I guess you can see that hopefully now you can do with generative AI. Will this still be 50-50? I don't know.
I was surprised by the answers. Oh.
Yes!
Ooh, okay.
Absolutely.
Maybe
Again.
we were very convincing.
And a cheer for it being a positive change to the world. A little bit, yes.